Okay, good morning. We're covering Geometry Lesson 6.4 on angle, side angle, and side. I'm sorry, angle, side angle, and side triangle congruence. So you're going to be able to recognize and prove that two triangles are congruent if two corresponding angles and the included side are congruent. That's angle, side angle. And you'll also be able to recognize and prove that two triangles are congruent if two, that's TWO, corresponding angles in their non-included side are congruent. So that's angle, side. Here are the two IXL skills that support this, K3 and K4. You're going to take notes on this and upload them to me. Again, include this header. The uploading must be done by 11:59 p.m. Saturday. Okay, so these are the two theorems, postulates. Remember, postulates are based on theorems, and sort of they're basically the same as a theorem. It's just that they're based on another theorem. So two angles, two additional shortcuts, basically, are what these are. So the postulate and the theorem are shortcuts that you can use to prove that two triangles are congruent. So angle, side angle congruency, we already mentioned this. Two angles in the included side of one triangle are congruent to two angles and the included side of the second triangle. So we have angle A here is congruent to angle D, and line segment AC, that's AC, is congruent to line segment DF. And then lastly, angle C, I've got two arcs here for that, is congruent to angle F. So what we're proving by that is then that triangle ABC is congruent to triangle DEF. The angle side angle congruence theorems says if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then again the two triangles are congruent. So we have angle A here is congruent to angle D. We have angle C is congruent to angle F. And we have line segment BC being congruent to line segment F. And that makes the two triangles congruent. Hence, we've got the congruent symbol here. All right. Okay, so we're going to do a paragraph proof. And what we want to prove is that the angle side congruence theorem is true. So what we're going to do is we have two triangles, and we're saying given that angle A here is congruent to angle D, and angle C here is congruent to angle F, then line segment BC here is congruent to line segment EF. If that's so, then what we hope to prove is that triangle AC is congruent to triangle DEF. So let's do a proof to see that this is true. All right, so let's see. It is, first of all, given to us that two angles of triangle ABC are, these two angles, two sets of angles, I should say, are congruent to the two sets of angles for triangle DEF. So let's say that first. All right, so it is given that two angles, we should have abbreviated that, we'll do that later, of triangle ABC are congruent to two, and now I'll use just the angle symbol, angles of triangle DEF. That's a given. Now, by the third angle theorem, because there's three angles in this, and we've got angle A and C and D and F covered, but angle B and C here, through the third angle theorem, they're going to be congruent as well. So I'm going to go ahead and mark these with three arcs, and we can say by the third angle theorem, which we previously covered, the third angle, I should say angles, of are also congruent, I'm sorry, are also congruent. Now, that would say then, that's meaning angle B is congruent to angle E. Okay. B and E, we showed that. All right, so notice that BC here is the side included between E and F, and also notice, let me restate that, BC and EF are the sides included between the sets of angles, angle B and angle C in this in case of it, triangle B, ABC, and angle E and angle F in terms of triangle DEF. So notice that side BC is the side included between angle B and angle C, and line segment EF is side included between angle E and angle F. Okay? So, bottom line is, therefore, you can apply the angle-side angle congruence postulate, which we showed on the previous slide, to conclude what we're trying to prove, that triangle ABC is congruent to triangle DEF. Okay? That's what we're trying to do. So now I'll put it straight so that you can see the whole thing and see what we've covered. And so we've got one more to do after this. Well, actually, before we do the last one, I want to do three very brief one-step proofs. Okay, just to get us kind of into the feel of this thing, and then we're going to do one more example. So the second example are three one-step briefs. So it says, is there sufficient information to prove that the following triangles are congruent? So we've got a set of triangles here. That's our example, first example. Then our second one, we've got a pair of triangles here. And our third example, we've got a pair here. And they all have various marks that basically are given information, right? So, so you look with the first one here, you'll notice that angle E and angle, well, first of all, let's see, EF, line segment EF is congruent to HJ, and then E is congruent to angle E is congruent to angle J. And actually they call this, I think, yeah, they just call it by E and J. So in addition to that information, we can also note that, let's see, this angle here, we'll have to use all three letters, EGF. EGF is congruent to JGH. Why? Because these are vertical angles. All right? And so now you have, let's see, two pairs of corresponding angles and one pair of corresponding lines. So I've got this angle here, and this angle here, and this angle here, and this angle here, and two corresponding lines. So that basically would allow me to conclude that this is congruent through angle, side. So because I have, again, an angle, side. Well, we can go this way. Angle, side, angle, side. Congruency. So let's write that up. Okay. So in addition, to the angles and segments, where it's kind of summarizing there, marked, angle EGF is congruent to angle JGH by the vertical angles theorem. Okay, and again we said two pairs of corresponding angles, which is what we have here. And one pair of corresponding sides, right? So again, we're kind of summarizing. Are congruent. Okay, so now we can make our conclusion. Therefore, remember I use these three dots to mean therefore. Therefore, triangle EFG is congruent to triangle GHJ. EFG, let's see, JHJ. Ugh, I can't say it. JGH. By the angle side. Theorem. Okay, so that's the first one. Now let's look at the second one. So the second one here, we've got the two sides marked, and I can conclude that NP is congruent to itself. So I can conclude that. So I've got two sides here, and this side congruent to itself. So that's basically two sets of sides for each triangle is congruent, but there's no other information here. So I have to conclude that there's not enough information to prove that these two triangles are congruent. So what I will write is, let's see, in addition to the congruent segments marked, we can say that NP is congruent to itself. So NP is congruent to NP, line segments, that is. So the two pairs of corresponding sides are congruent. That's what we can conclude. but this is not enough information. To prove these triangles are congruent. Okay, so now I can straighten it out. You can look at it. So we covered that one. Now let's do the last one. Now there's a lot of information on this last one. You've got two parallel lines, two pairs of parallel lines. And you also have a line, a diagonal that crosses it that actually acts as a transversal. So you've got angles here. So we can see that angle 1 here is an alternate interior angle to angle 3, and so that makes them congruent. Okay? So again, because you have parallel lines and a transversal, you could sort of extend this out if you wanted to think of the transversal, right? So two parallel lines or parallel line segments and a transversal, angle 1 and angle 3 have to be alternate interior angles because they're inside the two parallel lines and they alternate across the transversal, so they're congruent. And then similarly, angle 2 here and angle 4 have to be congruent because they're also alternate interior angles. They just alternate across the other side of the transversal. Now we can't say that angle 1 and angle 2 is congruent. We can't say that. We can only say that 1 and 3 are congruent, and we can say that 2 and 4 are congruent, but we can't conclude that 1 and 2 are congruent to each other and 4 and 3 are congruent to each other. That doesn't work with what we have learned in the past. Okay? So because of the fact that we have, let's see, what do we have? So we've got two angles, two sets of angles, two pairs of angles in the two triangles that are congruent. And what else do we have? Well, remember the transversal, it is congruent to itself. So this is WZ here. So WZ is congruent to itself. So we have angle side angle congruence. Okay. So let's write that up. So the two pairs of parallel lines parallel sides. Let's say parallel sides, even though they are lines. Parallel sides can be used, that angle 1 is congruent to angle 3 and angle 2 is congruent to angle 4. Why? Because of alternate interior angles. Interior, I misspelled that. Angles. And because the included side is congruent to itself, so this is WZ. Let's put WZ. Is congruent to itself. Then, therefore, triangle WUZ, that's this one here, the one in the upper left, is congruent to angle or triangle ZXW, that's this one down here, by the side angle theorem. Now, one of these is a postulate and one of these is a theorem. Let's just go back. Let's see, angle side angle is actually a postulate. So we'll call that a postulate, just to be belts and suspenders. Now, I'm not going to mark you off if you use theorem instead of postulate on these. That's a minor thing. These are all one-step proofs. They're paragraph proofs as well, okay? But you can easily see this, and the biggest reason I wanted to show this is because I wanted to be able to have you get the understanding of the notion of what's enough information. This was not enough information. Not enough information. Okay? So, that's it for this. Now let's go to the last example, example 3. And this is going to go fairly quickly because this is a two-column proof. And two-column proofs, just for some reason or other, they just flow nicely. I don't know why. But, okay, so you're going to prove using a two-column proof. And so the given is that AD, so here's A, here's D. AD is parallel to EC. And BD is going to be congruent to BC. So here's BD is congruent to BC. Now what are we going to prove? We want to prove that triangle ABD is congruent to the other triangle, which is triangle EBC. All right, so let's first do the givens. So we know that BD is congruent to BC. Okay, and so here's, let's put the line segment. Okay, put the right notation material. So here's BD, and it's congruent to BC. Okay, so those sides are taken care of, and that's given. And then the second given that we are given, I like that. AD is congruent to EC. All right, now I'm going to write given again. In some of our proofs, we would, it's just up to you. You could put these all together under one and just have one given and a space over here where the second one is. We could put a comma, we could have done that. So we could have had just one given with both of these two things in the information. It's up to you. This is a style thing, perfectly style thing. So you can do it this way or you can the other way. All right, so then the third thing is angle D here. Oh, well, we haven't really talked about what's going on here. So we know this. Now, what else, what other information we have? These are parallel lines, right? Parallel lines. This information was given to us. So since they're parallel lines, then this line here has to be a transversal, does it not? As does this line here. Okay? So if these are transversals, then we can prove certain angles are congruent using the alternate interior angle theorem. So now I want to prove. Well, let's just start with D and C. So let's say D here and C. These are alternate interior angles. So we can say that. Let's write it down. So angle D is congruent to angle C, and that's the alternate interior angles theorem. Now, I could show these other two angles as alternate interior angles, A and E. That would fit. And then I'd have angle-angle side congruency. I could do that. So that's one possibility I could do. So you've got more than one path here. But I'm going to choose angle side angle just for the heck of it, because I want to show you. Again, you know, these two angles are vertical angles. And since we've already used, well, because they're vertical angles, I can't call them both angle B. So I'm going to call in this first one ABD, ABD, and the second one I'm going to call EBC. Because again, that's one of the primary reasons why you use three letters in one place and one letter in another for angles. So let's just say that angle ABD, the first vertical angle, is congruent to angle EBC, which is the second vertical angle. All right? So, what's the reason? Well, because they're vertical angles. All right, and so then we want to do, well, now we've got enough information. We've got angle, side angle, angle, side angle. So this is easy. We can say now that triangle ABD is congruent to triangle EBC, and the reason is the angle side angle postulate. So again, I could have gone two different ways. Up here I didn't tell you which postulate to use or which theorem to use to prove this. So you could have used angle A and angle E as alternate interior angles and just ignored the vertical angle, and you would have had angle, side angle, angle, side angle congruency. Oh, I'm sorry. Not angle, side angle. You would have had angle, angle, side. Okay. And again, angle, 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 side congruency. You could have done that instead of angle, side angle congruency. All right. So it's just two ways to go. But this way is the way I chose, and that's it. So we're done. Thank you very much. Have a wonderful day, and we'll see you later.